Chapter 3 Review. Alright, so today we're going to learn about the first derivative test. And we're going to use the example y equals x squared plus 2. And this is the graph of that. And to look at that, we're going to use the first derivative test to determine a local max or a minimum. And say we're looking at a minimum. So we take the first derivative of it and you get y prime of x equals 2x. First you have to make sure that the point that you're looking at of x equals 2 actually exists. So you plug it into the original function and you get y equals 2. And then you have to make sure that the slope, there is no slope at x equals 2. So y prime of 0 equals 0. There's no slope. And to determine if it's a min or max, we'd look at the slope coming from both sides of that point. And from the left side, negative 2, is a negative slope because it's negative 4. And on the right side, there's a positive slope because it's positive 4. And because the slope is decreasing and then increasing, there is going to be a local minimum. And the same thing works for the opposite way. If it's a local max, like if the graph was like this, and the slope goes from positive to negative, then it would be a local max.
So the next topic in chapter 3 is Rolle's theorem. And so the wordy version is if f of a on the interval a to b on a continuous function, if f of a equals f of b, then f prime of c equals, like somewhere on that line, will equal 0. And what that means basically, so there's a point f of a and f of b, and if they are the same point, and if you draw a dotted line between them, it makes a line, a linear function with a slope of 0, then somewhere along this line there has to be a point because it's going up then down, negative then positive, so there has to be some point where f prime of c, which is the slope, equals 0, even if it was a linear function like this. And f of a was here, and f of b was here, and they equal the same thing. It would just be all the points would equal 0.
Go.
So for our mean value theorem, which is the next topic, this is the equation for it: f of b minus f of a over b minus a equals f prime of c. And so basically you use this when you are given two intervals but not enough information to differentiate.
Alright, now we're doing concavity. This is the graph of sine x. This portion here is concave down. This portion here is concave up. And the point at which it switches between the two concavities is the point of inflection.
Go.
Alright, now we're going to work on the second derivative test. So we have the function f of x equals x cubed, and the second derivative of that is 6x, and we can test where there is a point of inflection based off of when it switches from a positive second derivative to a... Alright, this is the second derivative test. It shows where there is a point of inflection on your graph. This is the function f of x equals x cubed, and the second derivative of that is 6x. Now, to show whether there's a point of inflection, you need to find where the second derivative goes from negative to positive. As shown here, the f double prime of negative 1 on x cubed is negative 6, and the f double prime of 1 is 6, and f double prime of 0 is 0, so you have a point of inflection at 0. Another thing is that when the second derivative is negative, as shown here, it is concave down, and when the second derivative is positive, it is concave up.
And now we're doing tangent line approximations. So this is the equation you use to find the tangent line approximation, and these will be the values that at that point that you're trying to find the tangent line, x1 and y1. And the question asks you to find the tangent line approximation of y equals x squared plus 3 at the point 2, 7. So you have to take the first derivative of this equation, you get y equals 2x, and you plug in this x value, and you get 4. So now you know the slope, because the slope is what the derivative is the slope at that point, is 4. So your m value will be 4. And so you plug all this into the equation, you get y minus 7 equals 4 times the quantity x minus 2, and that simplifies to 4x minus 1.